Okay, welcome to the 8-1.3 assignment. So we are still, our goal for the lesson is still to simplify expressions involving powers of a monomial. And today the focus is more on how to find a power of a power, and then we're also going to look at how to find the power of a product. So the first one that we're going to take a look at is the power of a power. So it says in the following examples, the definition of a power is used to find the power of a power. Look for a pattern in the exponents. So when you look at this, we're looking at what happens when we take 4 squared and we raise that to the 5th power. So if you think about what the definition of a power does, is that it takes the base and you want that to be your factor, and you are going to have 5 of those factors. So we've got 4 squared times 4 squared times 4 squared times 4 squared times 4 squared, and there are 5 of those factors. Now, when you think about our rule for the product of powers that we learned yesterday, we learned that if the bases are the same, then we can just add the exponents. So in all of these, the base is 4, and so we can just add 2 plus 2 plus 2 plus 2 plus 2, which would give us 10. So you would end up with 4 to the 10th power. Okay, so we started here with 4 squared raised to the 5th power, and when we simplified, it ended up as 4 to the 10th power. So now we're going to take a look at the second example. Here we have z to the 8th power raised to the 3rd power. So for this, we're going to have 3 factors of z to the 8th. So you'll note that there are 3 of these factors. And just like we said in the previous example, we're going to apply the rule for the product of powers. And since the base is the same, we keep the base as z. And then we have 8 plus 8 plus 8. When we do that, 8 plus 8 plus 8, we get 24. So we started with z to the 8th raised to the 3rd power, and then the simplified answer was z to the 24th. So it says that those are the answers. These and other similar examples suggest the property for finding the power of a power. So I'm hoping that you noticed, if you look, the relationship between the 2 and the 5 and the 10 is that 2 times 5 equals 10. So we took our exponents and we multiplied them together to find that simplified number. And here again, 8 times 3 is 24. So yesterday when we were multiplying our exponents, we added the exponents. Now that we are, yesterday when we multiplied our powers, we added the exponents. Now we are raising a power to a power, so we are going to multiply the exponents. And it just repeats that: to find the power of a power, multiply the exponents. So we're going to write this as, for any number a and all integers m and n, we're looking for it to say this. We want it to say, if a to the m power, in parentheses, is raised to the n power, all we're going to end up with is a raised to the m times n, meaning we're just multiplying our exponents. So a good example of this would be if we had k to the 5th power, we raise that to the 9th power. All you're looking at is this is going to be equal, we keep our base, we multiply 5 times 9, and the result is going to be k to the, and that's going to be 45. So keep your base, multiply your exponents when you're raising a power to a power. So now we're going to take a look at some examples here where we're doing this. So now, instead of just having a power to a power, we've got a power to a power to a power. But it doesn't really change anything. So in this, you would want to keep your base, and I'm going to focus in on just the first part, like we always do order of operations, what's inside the parentheses first. So we'll do what's inside the bracket first. And we just determined that when you have a power to a power, you're going to multiply your exponents. So we are going to have 3 raised to the 2 times 3 power, and then eventually we're going to square that whole thing. So we can do a little bit of simplifying. So this piece is what we just did. We can simplify that. That's going to be 3 raised to the 6th power, because 2 times 3 is 6. And then we still have it to the 2nd power. And so we're thinking, okay, this is going to be 3 to the 6th times 2, which is 3 to the 12th. And I know that this is a lot of work being shown. And I should highlight this to show that this is that simplified. Anyways, like, this is a lot of work to show. It is not necessary for you to show this kind of work as you go. But what I do want to make mention is that if you did 2 times 3 times 2, 2 times 3 is 6, and 6 times 2 is 12. You can jump, like, you can talk it out in your head and then just write the answer. Now for this one, same idea, like, I'm going to put down here my answer, but I've got 2 to the 3rd power to the 2nd power to the 3rd power. So I'm just multiplying these exponents. I keep my base, and then 3 times 2 times 3, 3 times 2 is 6, 6 times 3 is 18. Now I could work out my steps in between here, and I'll do that just so that you have a kind of an idea of what I was thinking here. So I do what's on the inside of the brackets first, so I'm going to focus in on that. So I have 2, and then to the 3rd power raised to the 2nd power, so I'm going to multiply my exponents. And then I'll have to raise that to the 3rd power because we've got this 3rd power on the outside. So that's this piece. Then we can simplify. So 2 to the 6th power, and we're going to raise that to the 3rd. And then we can go from here. We've got 2, and then we would just multiply the exponents again. I guess if we really wanted to be crazy, you could also write it like this, where you just have 2 raised to the 3 times 2 times 3. That would make most sense to me, I feel like, which ends up being 2 to the 18th. So I'm just going to put that in a different color because this is the alternative method. This is the one that I feel like makes a little bit more sense. All right, so this is what happens when you are doing a power of a power. In the next video, we're going to take a look at what happens when we have a product, so things multiplied together, raised to a power. So tune in to the next video.